Welcome to this short video on tsunamis. In the title slide here, we have a picture of the tsunami that struck Japan in 2011. This was a major natural disaster for the country and over 18,000 people died. This tsunami was generated by an earthquake, and in fact, that's how most tsunamis are generated. But as we'll see later in this video, tsunamis can also be generated by landslides. Here's the basic geological setup for the triggering of the earthquake and tsunami that struck Japan in 2011. Most tsunamis that are generated by earthquakes happen in subduction zones, and the Japanese tsunami in 2011 was no exception. So we have the Pacific plate subducting underneath the Eurasian plate. And as we saw in an earlier video, in these types of subduction zones, the subducting plate begins to melt, forming magma. And then that magma works its way up to the surface to form volcanoes. And so this is how the Japanese islands are formed. The Japanese islands are a volcanic island arc. Now, what you'll notice in these types of situations is that both plates are in contact right there, right at the top of the subduction zone. And there's a lot of friction between these two plates. And so as the subducting plate moves down, so there's that contact point, as the subducting plate continues to slide downward like this, it drags the other plate along with it. And so this other plate, as you can see, is being bent down. And so this essentially creates, like a deep spot in the ocean floor. Now at some point, the pressure, the stress gets too great on that contact point, and this black plate is just going to release, and it's going to snap back up. So here it is. We see now that the plate is snapped back up. This generates, of course, a big earthquake. And also, if we look at what happens to the surface of the ocean, it pushes up a big dome of water. And this is the birth of the tsunami. So again, it's the plate snapping up, pushing the water that's above it. Once you get this initial bulge of water on the ocean surface, it starts propagating. So in the next instant, we have that initial dome of water propagating away from that spot. And so this is a lot like the ripple you would get if you threw a big rock, say, into a pond. This gives you an idea of what that might look like from space. This is actually a simulation of an earthquake that might happen along the Aleutian Islands. To get you situated, so this is Alaska. And then we have the Aleutian Islands right here. In the Aleutian Islands, just like the Japanese islands, these are a volcanic arc formed in a subduction zone. And so in this simulation, the earthquake epicenter is right there, and you can see the tsunami waves generating away from that point. Now what you'll also notice is that these tsunami waves will eventually end up hitting Northern California, right here in red. And you might ask, well, has this ever happened in the past? Like I said, this was a simulation, but you might ask, is there any historical event when this might have happened? And in fact, there is, and not even that long ago. In 1964, there was a huge earthquake in Alaska, and in fact, it's known as the Great Alaskan Earthquake, and that generated a tsunami that worked its way down the coast of North America, eventually striking Crescent City, which is a town in Northern California. And this was a major event for that town. As you can see, it caused a lot of damage and a lot of flooding. So that's how tsunamis can be generated by big earthquakes, specifically those in subduction zones. But tsunamis can also be generated by landslides. And a classic example of a landslide generating a tsunami is a volcanic island suddenly collapsing. So we have an example here of a volcanic island poking up above the ocean surface. And what's going to happen is this side of the volcano is going to collapse. And these collapses can be a result of earthquakes, and they can be a result of volcanic eruptions, and they can also just be a result of the overall weakening of the volcano. When it's the side of the volcano that's falling apart, we call this a flank collapse. So we see that a big chunk of the volcano has failed and fallen into the ocean. As a result, this displaces a big mound of water that then races across the ocean as a tsunami. And one of these happened not that long ago. So this is in Krakatoa. This was in 2018, and this is what this volcanic island looked like before it collapsed. And this is what it looked like, and this is what it looks like now after it collapsed. The dashed line shows us what it used to look like, and so you can see that there's a big area here that just slid into the ocean. This generated an immense tsunami that ended up killing about 430 people in Indonesia. And here's a picture of some of the consequences of that tsunami. Okay, thank you for your attention. I hope that was helpful.